The same math that describes heat spreading through a bar of iron.
Today moves trillions of dollars on Wall Street, and once nearly brought the financial system down.
Things you've never seen now revealed.
This is Finance in Detail. In 1998, a single investment fund came so close to bringing down the world's financial system that the largest banks on Earth had to rush together to stop the disaster. The most frightening part? This fund was run by geniuses. It had 2 Nobel Prize winners on its board, and it used the most admired mathematical formula in the history of finance, a formula so powerful it had transformed Wall Street forever. So how did it nearly destroy everything? To understand, we have to go back almost 200 years to a speck of pollen trembling in a glass of water.
1827. A botanist named Robert Brown places grains of pollen in water and looks through his microscope, and he sees something that makes no sense. The grains are trembling, moving on their own, endlessly, in a nervous and completely random dance. There's no wind, no current, nothing pushing them. Yet they refuse to sit still. Brown describes the phenomenon carefully, but he cannot explain what causes it. And for almost a century, this tiny tremor stays a mystery no one can crack.
Hold on to that image. A random, unpredictable motion that looks like pure chaos. Because here comes the twist almost nobody knows. The first person to look at this kind of chaos and see money wasn't a physicist nor a billionaire. It was a quiet, overlooked French mathematician named Louis Bachelier. In the year 1900, in his doctoral thesis, Bachelier did something decades ahead of his time. He looked at stock prices rising and falling and realized they moved exactly like those grains of pollen.
Think about what he saw. The price of a stock in any instant might rise or fall, and no one knows exactly which way. It's a random walk, a tremble, just like the pollen in the water. Bachelier was the first person in the world to describe the mathematics of the market this way. And here's the incredible detail. He did it 5 years before Albert Einstein published his famous explanation of the very same phenomenon in physics. 5 years before. But Bachelier was a nobody. The subject seemed too strange, and his brilliant work was ignored, forgotten in a drawer for decades.
It's only in 1905 that Einstein finally explains the trembling pollen. The cause is water molecules, invisible, bombarding the grain from every side, millions of times per second. This random spreading has a name and a precise mathematics. It's diffusion. And diffusion is the same mathematics that describes something far more familiar: heat. The way heat spreads through a bar of iron, flowing from the hot end to the cold end, follows exactly the same equations: pollen, heat, and stock prices. 3 things that seem to have nothing in common, ruled by the same mathematics of chance.
And here our story leaps 70 years forward into the heart of Wall Street. 1973. 2 economists, Fisher Black and Scholes, with help from a third, Robert Merton, are chasing the solution to a problem that tormented the market: the problem of options. Let me explain it simply. An option is a contract that gives you the right to buy something, a stock, say, at an agreed price on a future date. It's like paying a small fee today to lock in the right to buy something tomorrow at a fixed value. Useful, powerful, but with one question nobody could really answer.
The question was simple to ask and devilish to answer. How much is that right worth today? How do you put a fair price on something that depends on an uncertain future? On a price that will tremble up and down like pollen in water? For decades, this was more guesswork than science, until Black-Scholes had their brilliant idea. They treated the price of the option as if it were heat spreading out. They took the same mathematics of diffusion, of Brownian motion, the same trembling of the pollen, and applied it to the market. And out of it came a formula that, for the first time in history, gave an exact price to uncertainty.
The impact was immediate and enormous. That same year, 1973, the first major options exchange opened in Chicago. And suddenly traders had a formula, almost magical, that told them the fair price of every contract. The options market, once small and confusing, exploded. Billions became trillions. The Black-Scholes formula became the most used equation in all of Wall Street, taught in every university, programmed into every trader's calculator. In 1997, Scholes and Merton won the Nobel Prize in economics for it. The mathematics of a pollen grain had conquered the money of the world.
And for a while, it seemed risk had been tamed. That the uncertainty of markets, that unpredictable tremble, had finally been boxed into an elegant equation. But there's a detail hidden at the heart of that formula. A detail almost no one wanted to see while the money poured in. The formula assumes the market behaves nicely, that prices tremble in a smooth, predictable way, like pollen in calm water. That the truly extreme days, the violent crashes, the panics, are extraordinarily rare, almost impossible. And that is exactly where reality plays its cruelest trick.
Because the real market is not calm water, it has storms. It has days when the impossible, according to the formula, simply happens. And in 1998, those storms all arrived at once. A fund called LTCM, the very one with Scholes and Merton on its board, the fathers of the formula themselves, bet fortunes trusting that the market would behave the way the equation predicted. For a while, it worked beautifully. They made rivers of money, until the real world did something the formula called all but impossible.
A chain of unexpected crises shook global markets, and prices moved in a violent, extreme way that the model treated as nearly impossible. The fund's losses exploded at a terrifying speed. And because it was tied to giant banks all over the world, its collapse threatened to drag them all down together like dominoes. The global financial system stood at the edge of the abyss because of a fund that trusted a formula too much. In the end, the largest banks had to rush together to catch the fall and prevent a catastrophe.
And here is the most important lesson in this entire story, the one that matters to you even if you never buy a single option in your life. The formula wasn't wrong. It's a masterpiece of mathematics. The mistake was human. It was confusing the map with the territory. A model is a simplified version of reality, a beautiful, useful picture, but never the whole of reality. And the danger lives precisely in the extremes. In the storm days, the formula smooths away. Whoever forgets that the model is only an approximation and starts treating it as absolute truth, sooner or later meets the storm it never predicted.
This changes how you should look at any number that promises safety in finance. Every projection, every calculated risk, every guarantee that looks exact is built on a model, on assumptions that the world will behave nicely. Most of the time, it does. But the real risk, the kind that truly hurts, is almost always hidden in the rare extreme nobody put into the math. Distrusting false precision, respecting uncertainty, remembering that behind every number lies an assumption. That is worth more than any formula. It is humility in the face of chance.
And still, what an extraordinary journey. From a grain of pollen trembling in water in 1827, to the equation of heat, to the forgotten thesis of an overlooked Frenchman, to the beating heart of Wall Street. The same mathematics of chance stitching together physics, nature, and money, showing that the world is far more connected than it seems. And leaving a reminder that no crisis erases. Our most brilliant formulas are mirrors of reality, not reality itself. And it is wisdom never to confuse the two.
So the next time you hear about an infallible model, a number that promises certainty, a formula that has tamed risk, remember the grain of pollen and the storm of 1998. Mathematics can be brilliant, but the real world always keeps a surprise no equation saw coming. And understanding that may be the most valuable financial lesson of all.
If this changed how you think about risk, subscribe to Finance in Detail. Next episode, why the market is actually too wild to fit inside a neat curve, and the genius who proved it by measuring coastlines. See you there.